Hi, my name is Cody Clark, and today we will be discussing SSH Protocol. Quick little table of contents we've got here for today's presentation. I'll start with a quick introduction, explain SSH Protocol, as well as the openSSH application on Linux servers, along with some hardening recommendations and a summary to recap everything that the presentation covered. So a quick introduction. Secure Shell, also known as SSH Protocol, is a cryptographic network protocol used to securely access and manage devices over an unsecured network. This presentation explores the technical composition and uses of the SSH protocol, with a focus on the Open Secure Shell application on Linux systems. We will examine key functionalities of Open Secure Shell, its role in secure communications, and why it's widely adopted. Additionally, 3 hardening recommendations will be presented to enhance the security posture of Secure Shell-enabled servers. The goal is to strengthen access control and reduce vulnerability to unauthorized intrusions. So first up, we've got SSH Protocol. So a quick breakdown. SSH, or Secure Shell, again, is a cryptographic network protocol used to securely access remote systems over an unsecured network, commonly the internet. It functions by using encryption to create a secure channel between a client and a server, allowing for secure command line access, file transfers, and remote administration. The primary purpose of Secure Shell is to protect data in transit from threats like eavesdropping, spoofing, and man-in-the-middle attacks. Secure Shell is essential in cybersecurity for tasks such as securely managing cloud infrastructure, automating administrative scripts, and deploying updates across remote servers. Secure Shell uses public key cryptography for user authentication, which makes it far more secure than traditional password-based logins. I've got this little infographic right here that I'm a fan of. I think it does a really good job depicting Secure Shell simply. It illustrates the Secure Shell protocol, showcasing secure communication between an SSH client, represented by the laptop, and an SSH server. Well, obviously, we've got depicted as a server on the right. It demonstrates how a message, such as a simple hello, is encrypted using a key, resulting in an encoded message, which you will see in the middle, which is then transmitted to the server. The server decrypts the message using its corresponding key to retrieve the original text. The mention of public key exchange highlights the use of cryptographic methods for secure data transfer. This visual simplifies the concept of Secure Shell protocol, making it easier to understand how encryption ensures secure communication over networks. openSSH, what exactly is it? So openSSH is an open source implementation of the SSH protocol that provides encrypted communication sessions over a computer network. It includes a suite of secure tunneling capabilities, authentication tools, and utilities for secure file transfer like SCP and SFTP. openSSH allows system administrators to remotely log into systems, execute commands, and securely manage infrastructure. Its purpose is to ensure confidentiality, integrity, and authentication in communication, making it a foundational tool in the cybersecurity and system administration space. For hardening recommendations on Linux servers for openSSH, first up, we've got disabling root login. Disabling the direct SSH login for the root user by modifying the SSHD config file. That function, this prevents attackers from directly targeting the root account, forcing them to compromise a lower privileged account first. The importance of doing this, this adds an extra layer of protection and enforces the principle of least privilege, reducing the risk of privilege escalation attacks. Second recommendation is using key-based authentication. Instead of just using passwords, configure SSH to use public-private key pairs for user authentication. The primary function of this, keys are significantly more secure than passwords alone because they are not susceptible to brute force or dictionary attacks. That is definitely a key point right there. The importance of doing this is this method reduces the risk of unauthorized access, and it's considered a best practice for authenticating remote users securely. Our third and final hardening recommendation on Linux servers, changing the default SSH port. Modify the default listening port from 22 to a non-standard port, for example, 2222, in the SSHD config file. The primary function of this is going to help reduce exposure to automated bot attacks and port scanning tools that commonly target port 22. The importance of this, while this is not a comprehensive security measure alone, it is definitely an effective way to minimize noise from opportunistic attacks. And as the summary here, openSSH is a vital component for secure system administration, offering encrypted remote access and file transfers. Its adoption across the industry underscores its importance in maintaining secure and resilient IT environments. Hardening an SSH server involves more than just regular updates. Implementing strategies like disabling root logins, using key-based authentication measures, and changing the default ports are crucial measures that can help ensure security. These techniques collectively reduce the attack surface and bolster the overall security of the server. By following these recommendations, organizations can improve their cybersecurity posture and defend against a wide range of threats. Thank you. And here's a quick page of my works cited. I definitely recommend checking out the U.S. Cybersecurity and Infrastructure Security Agency page on further detailing securing SSH protocol measures, as well as the Linux Foundation, the last work cited, securing remote access using SSH, has a lot of great information.